All right, folks, this unit that we're about to start is going to take us into projectile motion. That is motion where we have both a horizontal component, sort of a left and right, as well as a vertical component. And that's going to force us to do things a little bit differently. Whenever we're dealing with motion, most of the quantities we have are vectors. They have a particular direction with them. But the math that we want to do can only deal with one set of directions, either left or right, or up and down at one time. So the question becomes, well, what do we do when we get a quantity that is not perfectly in one direction? How do we deal with that to get it so we can just do one or the other? So a lot of what we're going to be doing is going to deal with triangles. So let's say we had a guy who went to the right for 100 meters, and then he turned north and went 200 meters. If I wanted to know his displacement, from last unit we know that the displacement is just the distance and the direction from beginning to end point. But neither of those two values tell me something. In the past we've just said, well, we're just in one sort of plane, left and right or up and down. We could just add those numbers, but here now we can't do that. We've got a whole separate direction. It's not 300 meters from that corner to that corner. Instead, we have to use some geometry and trigonometry to get that answer. So hopefully some of this is stuff you've already seen before in geometry. But if we've got two sides of a right triangle, like we have here, we can use the Pythagorean theorem to find the length of that third side. As long as we have any two sides, we can always find the third side using this theorem. So a squared plus b squared equals c squared. A and b are the legs, and c is your hypotenuse. Remember, the hypotenuse is the side that is across from the right angle. It is also your longest side. So either way of looking at it there. So here I know I'm going to pick A and B. I could have picked them the opposite way. I could have made that vertical piece the A side. It doesn't matter. So I've got 100 squared plus 200 squared equals C squared. So 100 squared is 10,000. 200 squared is 40,000 is C squared. And that gives us 50,000 is C squared. If I take the square root then, I should come up with 223 as my length. Because I had meters over here, it is also going to be meters right here. So being able to use Pythagorean theorem, we can figure out how far away our guy actually ended up from where he started. By using that theorem, we can take these two pieces and turn them into one and combine them into just one displacement. Instead of having to work in these two separate directions, we can combine them into one. We could do this also. Let's say we had a problem that said, all right, a man walked a distance of 1,000 meters in a straight line, and he ended up 450 meters north of where he started. How far west, or east, I'm sorry, did he get from where he started? So now instead of looking for the hypotenuse, we can actually find one of the legs. Again, we use the Pythagorean theorem. Legs get plugged in for A or B. 450 squared plus B squared equals 1,000. It's one too many zeros. Equals 1,000 squared. 450 squared is 200 and 2,500 plus B squared equals 1,000 squared, which is 1,000,000. If I subtract across, I get B squared equals that, and then square root. I get 893.0 meters. And that makes sense. That's a possibility. I have to make sure that both of my legs stay less than my hypotenuse. The hypotenuse must be the longest side. So that's just a way to check yourself. If we go back here, we also check, and that hypotenuse is longer than either side. So we know we are in business. So in order to get the length of that hypotenuse, the actual displacement, if we're given these two little pieces, we can take and use the Pythagorean theorem to get there as long as we have both of those two sides. In the next video, we'll talk about figuring out what this angle is. We also want to know the direction, right? If we have a displacement, we need a direction to go along with it. So that will be in the next video.